All right, another physics problem, collisions at right angles. Sometimes these accidents are referred to as a T-bone collision. So we have a 2,000 kilogram car traveling at 20 meters per second east. That car runs a red light and strikes a 1,000 kilogram car traveling north at 4 meters per second. So car number one has a momentum. It is m1v1, or 2,000 times 20 is 40,000. Car 2 has a momentum. It's 1,000 times 4, or 4,000. So now we need to combine these momenta, and if you see your formula, it says to add them. We cannot add. We cannot add because one of them is traveling east and one of them is traveling north, and you can only literally add vectors when they are in the same direction, and they are not. So east and north form a right angle. So we need to draw our triangle. And so I have my east vector that's very long because it represents 40,000. And I have my north vector, and remember, you always have to start the second vector on the head of the first one. And that's a measly little 4,000 kilograms meters per second, and it's headed north. All right, then I got my ruler out and drew my hypotenuse, and we know that a squared plus b squared equals c squared. So this square root of 40,000 squared plus 4,000 squared should be the length of our hypotenuse. So if we put all of that in, that will give us the magnitude of our combined momenta, the length of the hypotenuse. We're coming to that. And then what if we want to know direction, because vectors have direction? Well, we don't want to just say northeast, because northeast implies that I'm at a 45-degree angle, and this is much, much less than that. So we need to find angle theta. All right, next page. We do Pythagorean theorem. You can see it all drawn out here, the square root of all of that stuff. It comes out to be 40,199.5, so I just rounded it off to 40,200 kilograms meters per second squared. Does that seem legitimate? Well, if you draw the diagram semi to scale, I didn't exactly measure, but yeah, that hypotenuse looks like it's only slightly longer than that longest leg, so that sounds reasonable, 40,200. What is the angle? Well, if we were to go back to that triangle and look at where the angle is, the tangent of this angle would be opposite over adjacent. So we're going to take the inverse tangent of opposite over adjacent, 4,000 over 40,000, that's 0.1. Take the inverse tangent of that, it should be 5.7 degrees. Well, it looks like a very small angle, so that must be right. So my direction, if I'm asked for it, and technically if I'm giving the answer for a vector, I need to give its magnitude and its direction. It is 5.7 degrees north of due east. So we're going to add on to that problem a little bit. Hey, if the cars are stuck together, what is the velocity after the collision? All right, well, if the momentum before the collision was 40,200, then the momentum after the collision is 40,200. So we're going to set that equal to the masses added together, m1 plus m2, because they're stuck together, and they have a singular velocity. So 40,000, this is 3,000. 40,000 divided by 3,000 gives you 13.4 meters per second. Seems reasonable.